Wonderful. Okay, great. So, Miss Leila is a neuroscientist with a bachelor's in molecular biology and a master's in neuroscience. She completed her studies in Italy at the University of Trieste. I'm sure I'm not pronouncing it correctly. And in Finland at the Neuroscience Center of Helsinki, where she investigated the effect of antidepressant drugs in remodeling neural circuits responsible for addiction behavior for her master thesis. For her doctoral studies, she joined the lab of Professor Dr. Federico Calegari at the Center of Regenerative Therapies of Dresden in Germany, where she investigated the genetic regulation of the developing mammalian neocortex. Her research focuses on the role that different transcripts arising from the same gene as a result of alternative splicing have in determining the commitment of neural stem cells to a neural fate. This is extremely fascinating, and we have had no speaker come from a neuroscience background, so we are very excited to have you. Is there anything you'd like to say before we get into the questions?
I would just like to thank you for inviting me. It was very nice, and I really like the idea of these interviews with scientists. Like your platform is really, I think it can be very helpful. So thank you for taking this initiative, and thanks everybody for joining.
Of course. Okay. So my first question to you is, what is your background? We already spoke about a lot of things, but in your schooling, what were the subjects you studied in your schooling, your graduation, and your further studies?
Okay, so I actually started with classical studies in high school, so we were more focused in literature than anything else. And but while I was doing that is not really suitable for science, I was also reading other things about neuroscience and psychology and like the whole tricky effect that we can have on the brain when it's not functioning or when it's functioning well. And this brought me to then complement my education by my own with more scientific subjects. So I was reading articles, like divulgative articles about neuroscience already when I was in high school. And I was studying more maths and more biology by myself. And then I decided to go, of course, for molecular biology for my bachelor. And yeah, that was a broad subject, a broad course that we did. So we studied anything from evolution, classification, taxonomy, plant biology, as well as animal biology. And afterwards, I specialized myself more in neuroscience, like more on the circuitry of the brain, but also of the genetic regulation that brings to the formation of a mammalian brain. And that is actually why then I decided to go ahead with a PhD in developmental biology specifically. I got fascinated of how from few cells that are undifferentiated, we can get all the billions of different kind of neurons that allow us to think and to be who we are actually.
Wow, that is very interesting. That's amazing. And I think it just goes to show that to actually expand your horizon, because I would say a high school syllabus or what we study usually in high schools across the globe, not just in India, but it's very important for you to try and say read articles or try and get out of your
Yeah.
comfort zone, get out of your basic syllabus that you're doing, and try to read up about different things so that you get an idea of, okay, this also exists, or this is also something that can be done.
Yes, that is very important, and we never stop. I'm actually not considering to go ahead with another field that I know nothing about, and it's all completely new for me.
Exactly.
So yeah.
That's wonderful. Okay. My next question to you is, how did you decide that studying molecular biology and neuroscience was the right choice for you?
As I mentioned before, already in high school, I got intrigued by these articles that were talking about different aspects of the brain. I don't know if you're familiar with the story of Ines Gage, for example. It was yeah, exactly. So like how come such a injury of the brain could totally change the personality of an individual. And so my first approach was more on cognitive neuroscience, so like for the system and how this is impacting behavior, for study that either psychology or biology. And I thought that study biology would have been like the hardest part, and that would have been better to go through that path instead of the psychological part that I could maybe later on catch up on like more easily than going back and study like all the molecules. And so I already directed myself towards this, and I know that in Trieste there was already a very good neuroscience master, and that's why then I decided to go directly there before my bachelor. And as I said, like the more you study, the more you get to know different topics and field and subfield and all the open question, and you get amazed about how many things we still don't know and we can investigate. And then you get more and more specifically. So right now I'm not at all in a cognitive neuroscience lab, and I'm not drawn to that anymore. And I'm more on the genomic regulation and molecular biology that can bring to the formation of the cell. So like I'm already several steps ahead of the system, the cognitive system that is regulated.
Right, right. That is absolutely amazing. Okay, so my next question to you is, so you're a PhD candidate and you investigate, you also spoke about genomics and all. So you investigate the genetic regulation of the developing mammalian neocortex.
Yes.
So how is it being a PhD candidate? Would you recommend it to, not just neuroscience, but also like research enthusiasts in general? Like, would you recommend doing a PhD?
Absolutely. Yes, it's a very formative step. Either even if afterwards you don't want to continue in academia, which is the majority of us. Sorry, okay, I got confused. The majority of us is when not continuing academia because it's anyway a hard path, or like we lose of interest, or we want to have a more stable situation. But doing a PhD is a very formative period. You get to know how to actually work in the lab, and you develop several soft skills like managing your time and managing experiment, try alternative solution, because several times you're studying something that nobody did before, and also some established experiment might not work, and you have to find a different path to go to your goal. So you build a lot of different skills and a great resistance to frustration, because several times, as I said, the basic stuff don't work and you don't know why, and it takes patience and takes quite of a strength, like moral strength, to face these difficulties and go ahead. The most important thing I would say is to remember that these things happen and it's not your fault. You shouldn't compare your performance to somebody else. You can learn, of course, you can always learn by other people that are performing better than you, how they maybe manage their times or they tackle some difficulties. But you have to remember that if something is not working in your hand, doesn't mean that there is something wrong with you. You're there to learn. You're supposed to make mistake. Your goal is to learn from these mistakes and go ahead, and not thinking that if you are the problem. You're there to learn. So with all this formation, even if you don't want to continue in academia and do research in an academic setting, you can bring your skills, both the soft skills and the technical skills, in an industrial setting, or even doing other jobs. More consultant, for example. I have some friends that left the bench and now they're doing consulting for other people for research purposes. And other took more management position. So again, they're not working at the bench, but they're organizing other PhD programs, for example. So you really get to know a lot of things, and that you can sell in several different fields. So I would really recommend it.
Right, that makes a lot of sense. And I think it also goes to show that when you get into something like a PhD, it's fine. Like you don't have to give up. You have to keep going. And like you mentioned very rightly, it's not your fault that, it didn't work out. You have to keep going. And it's not like if you've done something that was very close to research, you have to continue in research. Like you mentioned, some of your friends are into the
Yeah.
industry, some of your friends are doing consultancy. So yeah. Okay, perfect. My next question to you is, this is, I think, my favorite question. It is that University of Trieste where you did your bachelor degree. It's in Italy. Okay, the Neuroscience
Yeah.
Center of Helsinki is in Finland. You also did like a period where in Cambridge in Babraham Institute, right? And right
Exactly.
now you're in Germany at Dresden Institute of Technology. So this is amazing that you've been in four different places and you're, pursuing your neuroscience, molecular biology, and all of that. So can you tell us how has it been studying in different places? Was it helpful that you were studying in different places, or what were the drawbacks and what were the great things about it? Yeah.
So it's sort of a requirement, I have to say, in academia. They really value a lot the fact that you moved in different countries, in different institutes, and you adapt yourself to different situations and different labs. So formatively is very important because you get to know how other people approach different things, how other country manage the research, and you you really learn to adapt to different situations and take the good stuff with you as well. You mentioned that I was in Helsinki. In Helsinki, I actually studied and did some exams, and the way in which the teaching and the examination were conducted was totally different than what I was used to in Italy. So it's also a cognitive exercise, so to say, for yourself. And on top of this, it's very important for you as a person in order to expand your zone. You get out of your comfort zone, you get used to different culture, to different way of living, also to different climates sometimes. And you get to know more about yourself and more also about the world that is around you. So it's really helping you to expand to expand your horizon. And on top of this, you get to know a lot of people, and this is the fun part of moving around the different countries. You get to become friends with persons that otherwise you will never have met, and that can really enrich your life. And the drawbacks is that if you keep moving, as it often in academia, you always have to say goodbye to these new friends. So it becomes a bit harder with time when you want to have a more established social situation, some long-term friends, and also in the case in which you want to have a family, then moving again becomes tricky. But it's the life of a scientist that happens very often.
Right, right. That makes a lot of sense.
Yeah.
And I think every new culture or the new set of people that you're exposed to, like you mentioned, you learn something new from them. It's different perspectives. So I think, I mean, personally, I feel like it's great going to four different places. But just like you mentioned, the drawbacks that you might just get used to this certain set of people, and you've all forged connections, and then all of a sudden it's time for you to go, or all of a sudden now you have to
Yeah.
move on to another place. Right. Okay, perfect. My next question to you is, how do you think STEM will progress in the coming years?
Oh, we have a lot of great advancement right now. I'm sure you're familiar with the CRISPR technology, and that is allowing a lot of application also in therapeutic settings. Things are moving also in that direction right now.
Right.
And it's also allowing to develop new tools for investigation purposes. It's incredible how much this expanded in the last few years. We're able to really target a specific mutation, a specific insertion in specific places. And this is allowing us to really study way more the function also of an encoding genome, for example, or we can tag, we can follow also the endogenous expression of some genes by modifying a bit their sequence and putting a reporter there. And so I think this is one big area that is gonna expand even more, because we just have a magic wand to open a lot of investigation in that field. And another big topic right now is the single cell sequencing. We're now able to get to know, so we can identify several new cell types by sequencing their expression, the gene expression individually. And we are now moving also to combine this with a spatial resolution of the cells and also of the single transcripts that are there. So we're getting to know way more the complexity of the biological system right now. And at the same time, we're developing a lot of tools to play with that. So I think those are the two big topics that I see are going to progress, at least in the biological field. And another one that I would say is the combination of biology and physics. We are more and more understanding how the physical property of the cells are actually influencing the development of their organism or their behavior. So this is another aspect that is developing pretty fast.
Right, that's amazing. In fact, we've had someone that works in a quantum biology tech lab, and she also
Yeah.
talked about the intersection of biology and physics and how it's booming, and how intersection, like fields that are intersecting. It's very important for research and to have fields that intersect, because that's when it expands horizons to another kind of a level. And I'd just like to bring up an example of when there was a researcher that was trying to research about, protein markers. And just when that happened, they actually found out that jellyfish, like he was trying to research how jellyfish glow in the dark. And that's how they
Mm-hmm.
realized that there are these fluorescent protein markers. And
Yeah.
so I think it's very important for interdisciplinary research, as a lot of people are pointing out in the chat box. So yes, absolutely, 100% agreed. My next question to you is, how has your experience been working on alternative splicing and mammalian neocortical development? And can you tell us how it has been being a researcher in the pandemic?
Okay, so my specific project was quite tricky, I have to say, because we still don't have a good analyzing pipeline for the data that I had to study. It's a very complex phenomena, alternative splicing. Basically, it, it implies the inclusion or exclusion of certain part of the gene in the transcript. So from the same gene you can have several transcripts, several functions. And since these different transcripts, of course, share a lot of similarities, by sequencing, it's pretty hard to identify which regions are included or excluded, and in which and to which degree. You really have to get a deep sequencing data, very high quality, and there are several bioinformatic pipelines to analyze this data. So I found it pretty challenging also because we wanted also to manipulate such changes in vivo, and so we have to be sure about which transcript are there. So it's one of the projects I would say it can be defined as frustrating, but I really got to love it, and I really push myself to get to know more and more, and I'm proud that I managed to overcome several obstacles and to get to a more complete story right now. And what was for me is also that I was kind of isolated because it's not such a common topic, at least not in Dresden. So that also brought me to find outside of this community people that I could talk to and to which I could exchange ideas and they could help me, for example. And I think this is also important for a scientist, that if you have to find the right people to ask to. It's really something, it's your project, it's your responsibility to make it go ahead. Personally, the pandemic didn't affect me so much because it happened in a period that was quite close to my to ending my research, my studies. So I could really go ahead. I was not slowed down by the pandemic because I could do a lot of work just with my computer. I didn't have to redo experiments on the bench back then. Of course, it affected mentally because it was a very strange time, a very strange feeling, being deprived from one day to the other of all the common freedom, let's say, that we were used to. Also, not being able to see friends at the end of a day of work was pretty stressful. But work-wise, I personally wasn't affected. I know other people that do experiment at trash, for example, the Salvatore cell culture, because we're not allowed to go, and they will just die. So a lot of people that I know had several delays, and that was a big damage. But other people that could do something at home by analyzing data or researching more their own topics so that they could propose good development of their project, they were not too much affected. So I saw a lot of scientists finding a way to anyway go ahead with their work also in the pandemic time. So it's also kind of a creativity. And it also gave the opportunity to several people to deepen their skills. I know several friends of mine were not used to work with the bioinformatic tools, for example, and they took the pandemic and the lack of bench work to start to learn these skills. It's also like one way to get yourself still active and not feel like slow down and still feel in control of your time and your life.
Right, absolutely. And I think it has also made us realize our mental health. Even you spoke about it. Mental
Yes.
health is very important. So, we should take time out. No matter which stage we are in life, we should take some time out for ourselves, prioritize ourselves at certain situations. Okay.
Totally.
Yes. Okay. Great. So my next question to you is, how do you feel about the underrepresentation of women in STEM? Have you personally ever faced any discrimination?
No, it's actually quite funny because I want to say that the representation of PhD student is 50-50, male and female, and some years is even more female than male. And I think the problem comes towards the end of your PhD and afterwards in the postdoc. We had several brilliant female PhD students that didn't continue with the postdoc because it comes with an age in which you want to stabilize and get a family, for example. And this is making the academic choice even harder. I know that like there is a way more awareness right now about the female representation in academia and in science, and there's a program that I help in it. I personally didn't feel discriminated during my study because I was a female, but I noticed, and also the people noticed, that usually female scientists are worse in selling themselves. We are usually more concerned, more self-conscious, we take less risk. We don't promote that much our research. We prefer to decline a talk in a conference, for example, because we're usually more anxious than the males. And this is making a lot of difference. I saw male PhD students that could sell like as amazing what they've done, even if they knew that the project was not going anywhere. Like I knew personally that the project was about to be shut down, and they didn't find anything, and they would have trashed 2-3 years of their work and start with something else. But they had the occasion to go to a conference and they had to show that project, and they made it sound like it was perfect and amazing, and then people get to that, remember them, go to them, they establish collaboration, and this is what is making a scientist go ahead. I know, for example, myself, I wouldn't have been able to do that. I would have been like bummed out, and I would have said like, this didn't work. I tried this, and didn't work. So I'm just shutting down this project. So I think there is a lot to work on the let's say the personality, more or less, of female scientists. Like more of a personality was the awareness of our value and the fact that we actually deserve this position and we have to fight for them. Not in an aggressive or dishonest way, but we are there for it because we deserve it, and we also should be able to get to a more important position. So it's really a matter of culture and personality, and I'm seeing that changing likely. I see a lot of institutional support to female scientists. Also the age to ask for grant afterwards, they take into account the maternity leave, and there are actually pressure to hire more scientists, more female scientists in a high position. As of today, still the female scientists that are working as PIs, so principal of investigation in Dresden, can be counted in one hand. But 3 of them came in last year, for example. So I see it's the right time now to change. It's the right time now for female scientists also to go ahead with the academic career. We just need to be aware of our value and really believe in ourselves, and yeah, probably also work on our skill to promote our career.
Absolutely. And I remember once we had Paula Garcia Todd, who is a global strategic lead for pharmaceutical solutions at DuPont Chemicals. She's a chemical engineer. And
Yeah.
she also said this, that it's extremely important for women to, not prove their worth in an aggressive way, like you said, but prove it in a way that they know that you're here because you deserve it. Like you mentioned, there are these programs wherein sometimes companies or universities are supposed to hire female scientists. So a lot of
Yes, exactly.
times, yes, a lot of times when these female scientists are hired, they are told that they got a certain job just because of this reason, which is so wrong, because they got it because they deserve it. They did not get it just because they had to fill in a position with a female scientist. So I think it's very important for women to be upfront about it and address any kind of bias if it comes their way. But like you mentioned that you feel like the personality of women in STEM is literally, is a little introverted. They don't really express
Yeah.
themselves, they're anxious. So, do you have any tips for, women that are, so we also have a lot of college students here. We obviously have a lot of high schoolers. So, do you have any tips for girls and even say boys that how exactly do you address these things? How exactly do you try and open up, or how exactly do you try and become a little more upfront about it?
You have to take the risk, and as more as you're aware that something is a problem for you, the more you have to work on it. Is the only way. If you know that you're not good in giving presentation, for example, I'm not good at all in giving presentation, I get very nervous. Then I have to prepare way more. I have to be ready with all my slides in advance, and I have to rehearse my talk several times. Not to know it by heart, but to
Uh-huh.
know what to say and try to engage more the audience as well. This is another problem, because the presentation in a scientific setting is not only about your data, it's also is a dialogue with the audience. So you
Right.
really have also to give presence and interest them and make them passionate about what you are passionate about. So that means just a lot of more work to do. If you have an issue, the only way is to work on this. Like with any other skill, if you know that you're bad in math, you have to do more exercise.
Absolutely. That makes a lot of
And
sense.
yes,
Right, right. Please
and
continue.
then
Please continue.
with any win that you get, anytime that you give a good presentation, anytime that you get a good feedback, the more confident you become, and the less of a problem this is gonna be. So just don't be paralyzed by your fear, and don't accept that the problem that you have, like an handicap, let's say, is there forever. You have the ability to change. You have the ability to overcome this.
Right, absolutely. Okay, so this will be my last question to you, which means that after this, I mean, the audience members can already start asking their questions in the chat box, and I will be recognizing them one by one. So, ma'am, my last
Okay.
question to you is, do you have any final piece of advice for us budding girls and boys in STEM?
Um, Follow what you're passionate about, not what is in the hype, because in the hype you're gonna find a lot of people that are there, a lot of competition, and if you don't like it, if you don't like what you're working on, and you have on top of this also a lot of competition, you're not gonna succeed. So find what you're passionate about, follow that. Be open also to other things. Be always up to date with what is going on, because right now the field of biology, biotechnology, and physics are really expanding at a pace that is incredible. You cannot know everything, so make your peace with that, but try to get at least an overview of what are the direction, what is coming up, and what this means for you as well. If you can see your research taking advantage of new technology in the field, or if new findings can give you another perspective on what we actually see. This is very important. And another piece of advice, try to make as much experience as soon as possible. I know a, a good a good attitude of several PI is to see the personality and the intellectual capacity of the student, even if they don't have any experience, because they say like this person is smarter and they can learn whatever in a couple of weeks. This is true. So if you don't have experience in a certain field, don't be scared. You can learn. You learn faster. You learn it at your pace, and it's fine. If you just pay attention, you go. It's not gonna take you forever. But being used to the work, to the bench work, is making you aware of a lot of problems, and is making you it's not only the problem, you get to know, yes, but this technique is easy to learn, but sometimes doesn't work. And if you just study in the book, you don't know that. So you start already to learn how to deal with the frustration and to learn the little tricks to make things work. But on top of this, you really get to have a more precise idea of what we're talking about. Because you can study as much as you want in textbook, you can see as much as you want YouTube videos or other lectures, but until you're there and you have to deal with your hands an experiment, you don't really get to know what we're talking about. And I think that is very important. And there are some techniques that require a lot of fine motor skills. So even if you don't have the ability now to do some surgeries on mouse, for example, but you know that you're interested in that, I would suggest to find yourself an hobby that you like, of course, that is allowing you to do something manual. Can be something as simple as cooking, or can be some more complex thing like miniature stuff. It's important to know that when you work in a biological lab, you're doing a manual work, not only a mental one. So that would be my suggestion, to try as soon as you can to do some internship, some experience in person.